One resident of Isfahan, the Iranian city sitting in the shadow of Sofe Mountain, described to journalists what the war has looked like from his window every single night since February 28, 2026. This mountain, he said, we see it get bombed almost every night. We see the smoke rise. Yet when we wake up in the morning, it is from these very same mountains that we see missiles rising into the sky. That sentence is not propaganda. It is not spin. It is a civilian witness account of the central military paradox of the Iran-US war. And it describes a problem that the most powerful conventional air force ever assembled, carrying the most powerful non-nuclear bomb ever built, has been unable to solve across more than 3 months of sustained bombing. Iran hid its missiles under mountains. It has been doing so for 20 years. And when the United States unleashed its most extreme response, 7 B-2 stealth bombers, 14 30,000-pound bunker-busting bombs, strike packages that combat operation in American history, the mountains held. The missiles kept flying, and the morning after each bombing, as the smoke cleared from Sofe's scarred surface, the launchers came back out. To understand how Iran built something that the United States cannot destroy, you have to understand that the underground missile network was not a rushed construction project. It was a 20-year engineering campaign, begun after watching America's first Gulf War demonstrate what happens to military hardware that sits in the open against the U.S. Air Force. The lesson Iran drew from watching Iraqi armor burn on the Basra highway in 1991 was direct and permanent. Anything that can be seen can be killed. The solution was to make everything invisible. Beginning in the early 2000s, Iran's Islamic Revolutionary Guard Corps Aerospace Force began constructing what it eventually called missile cities, a network of tunnels, underground launch chambers, storage facilities, maintenance bays, and logistics corridors carved into mountain ranges across Iran's interior. The Zagros Mountains, the Alborz Range near Tehran, the ridges south of Isfahan and north of Kermanshah, all of them became components of an underground military architecture whose full extent American intelligence spent years mapping, and whose depth and redundancy American planners spent years underestimating. The scale of what Iran built inside those mountains has only become fully apparent through the combination of Iran's own carefully timed disclosures and the satellite imagery that commercial providers have been publishing since the war began. In March 2025, before the war started, Iranian state media released an 85-second video that showed IRGC Chief of Staff Major General Mohammad Hossein Bagheri and IRGC Aerospace Force Commander Amir Ali Hajizadeh riding through a tunnel complex on what appeared to be a modified golf cart, passing rows of ballistic missiles stored along the tunnel walls. The missiles visible in the footage included the K-Bar Shekan, the Ghadr H, the Sejil, the Haj Qasim, and the Pave land attack cruise missile, some of the most advanced systems in Iran's inventory. The tunnel was wide enough to drive vehicles through. The missiles were stacked in organized rows. The facility had lighting, ventilation, and what appeared to be maintenance infrastructure. It looked, in the words of one analyst who reviewed the footage, less like a cave and more like a factory floor that happened to be inside a mountain. When the US and Israel began planning their strike campaign against Iran in the weeks and months before February 28, 2026, they were planning against an adversary that had spent 20 years building exactly this: an underground military-industrial complex designed to survive everything America could throw at it short of a nuclear weapon. The GBU-57 Massive Ordnance Penetrator is America's answer to hardened underground facilities, and it represents the absolute limit of conventional strike capability available to the U.S. Air Force. The bomb weighs approximately 30,000 pounds, nearly 14 metric tons, and is built from high-strength steel specifically designed to punch through reinforced concrete and rock before its 6,000-pound warhead detonates inside the target. It is precision-guided using GPS and inertial navigation systems. It can penetrate approximately 60 meters of reinforced concrete, deeper than the Channel Tunnel, as BBC Verify noted in its reporting, before the warhead detonates. The B-2 Spirit stealth bomber is currently the only aircraft in the world designed to carry the GBU-57, and each B-2 can carry exactly 2 of them. During Operation Midnight Hammer in June 2025, B-2 bombers dropped 12 GBU-57 bombs on Fordow and 2 on Natanz, in what represented the weapon's first operational use in history. During Operation Epic Fury on February 28, 2026, the weapon was used again at multiple sites. The Air Force subsequently awarded Boeing a sole source contract to produce additional GBU-57 rounds, a procurement action that confirmed both that existing stocks had been significantly depleted and that the U.S. intended to continue using the weapon against Iranian underground targets. The results of these strikes, measured not in the immediate press conference language of a spectacular success, but in the satellite imagery published weeks and months later, tell a story of genuine damage combined with genuine limitation. At the Fordow fuel enrichment plant, The facility buried inside a mountain near Qom that Israeli and American planners had spent years arguing only the GBU-57 could defeat. Operation Midnight Hammer's 12 bombs caused severe damage that CIA Director John Ratcliffe said would take years to rebuild. That damage was real, but Fordow was primarily a nuclear enrichment facility, not a missile storage site. The distinction matters. At Iran's missile cities, the underground complexes that store, maintain, and launch the ballistic missiles that Iran has been firing at Israel, U.S. bases, and Gulf Arab states, the picture was more complicated. The Talagan 2 facility at Parchin, east of Tehran, was struck in the February 28th strikes after having been significantly hardened in the preceding months. Satellite imagery showed it encased in concrete with soil layers added, and imagery from March 11, 2026 confirmed. It was hit, but the entrances, not the interior chambers, are what American bombs can reach. The missiles stored inside the mountain are below the bomb's penetration depth or behind enough rock that even the GBU-57's 60-meter penetration limit leaves the deepest chambers intact. The Sofei mountain complex south of Isfahan became the most vivid single illustration of this limitation. According to Defense Security Asia's May 2026 analysis, the complex was struck repeatedly by B-2 Spirit and B-52 Stratofortress aircraft. Throughout the bombing campaign, with precision-guided penetrators targeting entrances, storage chambers, launch infrastructure, and buried logistics corridors. The strikes caused visible damage: smoke, craters, collapsed entrance sections, debris fields visible from commercial satellites and from the windows of Isfahan residents watching through the night. And yet, according to the same analysis, the underground complex never remained offline, longer than approximately 12 hours before launch activity resumed from the same mountainous zone. Bombed 20 times, still launching missiles is not a triumphalist Iranian propaganda slogan. It is the assessment of open-source intelligence analysts, confirmed by satellite imagery, validated by U.S. intelligence estimates that Reuters and CNN cited through April and May 2026. American intelligence reportedly concluded that Iran retained approximately 70% of its mobile launchers and missile inventory, despite months of intensive air operations. The Sofei mountain complex was a case study in how hardened tunnel systems, combined with rapid engineering adaptation and sufficient underground depth, can sustain operational continuity through bombardment cycles that would destroy any surface military asset. The tunnel entrance problem is where the tactical limitation becomes most precisely measurable. American and Israeli strike strategy against the missile cities focused primarily on targeting the surface access points, the portals, access roads, ventilation shafts, and surface logistics infrastructure that allow missiles to be moved in and out of the underground complexes. The logic was the same logic that Ukraine applied to the Kerch Bridge. You cannot necessarily destroy what is inside the mountain, but you can seal the door and deny access to what is inside. This strategy produced quantifiable results in the short term. Satellite imagery after the February 28th strikes showed 69 tunnel entrances across 18 underground missile facilities struck and blocked, with craters and debris preventing immediate access to the missiles stored below. Iran launched significantly fewer ballistic missiles in the weeks immediately following the strikes, suggesting the access denial was having real operational effect. Pentagon briefers cited this as evidence of strategic success. Then, as CNN's reporting from May 31st, 2026 documented in the detail that made it one of the most significant intelligence disclosures of the entire war, Iran sent bulldozers. Iran sent dump trucks. Iran sent construction vehicles working around the clock at 10 sites simultaneously, clearing the rubble from 50 of 69 struck tunnel entrances within approximately 3 months. At the Isfahan North Missile Base, craters that had blocked 2 entrance roads were filled in and the roads repaved. At Khomeini, satellite imagery from April 15th showed at least 10 construction vehicles working a single tunnel entrance. The door that America spent hundreds of bombs sealing was being reopened by equipment you could rent from any commercial contractor. The GBU-57 intact capture is the development that introduced a dimension to this story that goes beyond the immediate operational picture into long-term strategic implications. Iranian reports from Zanjan province, first published in April 2026 and cited by Defense Security Asia's analysis, claimed that 4 GBU-57 bombs were discovered after strikes, 3 destroyed on site, but 1 fully intact weapon recovered and handed to Iranian authorities. If accurate, Iran possesses a complete, unexploded specimen of America's most advanced conventional bunker-busting weapon. An intact GBU-57 provides potential insight into Fuze sequencing, terminal penetration behavior, hardened casing metallurgy, and sensor survivability under extreme kinetic stress, technical information that directly influences both defensive architecture design and the development of countermeasures. The precedent that makes Western analysts take this claim seriously is the 2011 RQ-170 Sentinel stealth drone capture, when Iran displayed an apparently intact American stealth aircraft that U.S. officials initially dismissed as impossible, but that subsequent analysis confirmed had landed largely undamaged on Iranian soil. Iran had already claimed in late 2025 that it was working toward developing indigenous Earth-penetrating warheads inspired by GBU-57 operational characteristics for integration into its Fatah hypersonic missile family, claims that, if the intact bomb capture is accurate, now have a tangible engineering basis to build from. The broader damage assessment that U.S. intelligence produced by late May 2026 tells a story of genuine strategic impact combined, with genuine strategic limitation that neither full success nor full failure captures accurately. 90% of Iranian underground missile facilities were assessed as at least partially operational, according to the Jerusalem Post's reporting on May 31st, citing U.S. military agency assessments. Iran retained approximately 70% of its mobile launcher inventory. Experts told CNN that Iran still had approximately 1,000 missiles stored in underground sites, with that stockpile deep below the surface unlikely to have sustained much damage from strikes at ground level. The 1945 analysis from April 16th, summarizing the operational picture after 6 weeks of intensive strikes, stated flatly that while targeting Iranian leadership and naval vessels had been accomplished relatively easily, the U.S. had had less success destroying Iran's large network of underground bunkers that assemble and store drones and ballistic missiles. One German researcher who studies Iran's missiles told CNN directly, they were preparing for this kind of war for 20 years. That sentence contains the entire explanation. The bombs the U.S. dropped on Iran's mountains were devastating. 20 years of preparation for exactly those bombs made the mountains capable of surviving them. China drew its own lesson from the GBU-57's performance against Iranian underground sites. The Asia Times reported in March 2026 that China was moving to bury its own critical assets deeper underground following the Fordow and Natanz strikes, with Chinese energy experts proposing an extensive network of underground infrastructure across western China to protect strategic energy and defense assets. Zhang Shishu, chief technical expert at state-owned Power China, said critical facilities should be embedded deep underground with protective structures. China watched Iran absorb America's most powerful conventional weapon and keep launching missiles. It is now building its own underground architecture with those lessons incorporated into the design. The operational reality the United States faces in June 2026 is one that the Safed Mountain resident captured better than any Pentagon briefing. The U.S. dropped the most powerful conventional bomb ever built on Iranian mountains 20 or more times. The smoke rose. The mountain kept launching. Missiles. American intelligence now assesses that 90% of underground missile facilities are at least partially operational, that Iran retained 1,000 missiles in its underground stockpile, that 70% of mobile launchers survived, and that the tunnel entrance clearing operation exceeded all American timelines for recovery. The U.S. Air Force has ordered more GBU-57 bombs from Boeing. The production line is running. The B-2 bombers are maintained and ready. But the mountain that was bombed every night, from which missiles rose every morning, has not been silenced by the weapon that was specifically designed to silence it. Iran hit its missiles under a mountain. America unleashed its absolute limit of conventional strike power. The mountain held. The missiles flew. And the morning after the bombing, the smoke cleared, the bulldozers came out, and the construction vehicles began clearing the rubble, one truckload at a time, for the next launch. The mobile launcher dimension of Iran's underground missile architecture is the specific element that makes the entire American strike strategy structurally insufficient. And it deserves precise examination because it explains why 90% of facilities remaining operational after months of bombing is not a contradiction, but a design feature. Iran's ballistic missile force does not depend exclusively on fixed launch sites carved into mountains. Its mobile launchers, transporter erector launcher vehicles that carry missiles on trucks, drive to launch positions, fire, and then relocate before U.S. ISR assets can identify and strike them, represent a capability that underground facilities support but do not require. The Ahmed, Qadr, Khorramshahr, Fatah, and Khaybar-Shekan missiles that Iran has been firing at Israel and U.S. bases can be launched from mobile platforms that drive out of the mountain, set up in a field or on a road, fire within minutes, and then disperse back into terrain or back into tunnel entrances before a retaliatory strike can reach them. U.S. and Israeli strike packages have been targeting these mobile launchers since Operation Epic Fury began, with mixed results. Satellite imagery from March 1, 2026 showed what appeared to be an intact launcher traveling along a road near the Isfahan missile base, and a crater in the road nearby suggested a strike attempted to hit the vehicle but missed. The launcher was moving. The strike was aimed at where it had been. The physics of mobile warfare in mountainous terrain gives the defender a structural advantage that no amount of bunker busting can overcome from the air. The missile's launch preparation time, from driving out of the tunnel to first launch, is measured in minutes. The response time for a targeting cycle, detect, identify, target, strike, is measured in the same minutes in the best case and in hours in the worst case. Iran has calibrated its launch and move protocols specifically to operate inside the targeting cycle's minimum response time. The Fordow 2 hypersonic dimension adds a qualitative layer on top of the quantitative underground stockpile problem that the United States has not yet found an answer to. On March 1, 2026, Iran fired what analysts confirmed was the Fordow 2, its hypersonic glide vehicle missile, in combat for the first time. The weapon uses a maneuvering re-entry vehicle rather than a standard ballistic trajectory, allowing it to change course in the terminal phase of its flight and approach targets from unexpected angles at speeds exceeding Mach 5. The standard ballistic trajectory of Iran's older missile systems can be tracked and intercepted by American THAAD and Israeli Arrow 3 systems because the physics of the trajectory produce a predictable flight path. A hypersonic glide vehicle that maneuvers in the terminal phase does not produce a predictable flight path. Military Watch magazine assessed the Fordow 2 as nearly impossible to intercept for current air defense systems. The missile reportedly struck a fortified Israeli Defense Forces command center on its March 1st debut, reportedly causing the deaths of 7 senior officers. Iran has been producing the Fordow 2 in the same underground factories that American bombs have been trying to reach. Its production facilities are stored inside the same mountains that B-2 bombers have been striking for months. If 90% of those facilities are at least partially operational, and Iran retained 1,000 missiles in its underground stockpile. The portion of that stockpile that includes Fordow 2 systems represents an air defense challenge that Israel's Arrow 3 batteries, already running low on interceptors, are not guaranteed to defeat in a sustained salvo. The interceptor depletion mathematics that surround Iran's underground missile survival connect the story of Safi Mountain's resilience directly to the question of who is winning the attrition contest that this war has become. The United States and Israel are consuming interceptors, THAAD, PAC-3, Arrow 3, at rates that their production lines cannot replenish on normal procurement schedules. Kelly Grieco of the Stimson Center stated it plainly on February 28th. We are using these interceptors faster than we can make them. Israel informed the United States in mid-March that it was running critically low on ballistic missile interceptors. Iran, meanwhile, is launching from mountains that kept their missiles through 3 months of the most intensive conventional bombing campaign since the Gulf War, retains 1,000 missiles in underground storage, kept 70% of its mobile launchers operational, and reopened 50 of 69 bombed tunnel entrances within 3 months. The trajectory of this specific exchange, Iran's missile survival rate versus US and Israeli interceptor depletion rate, is the underlying structural dynamic driving Iran's strategic calculation that time is on its side. Every night that the mountain absorbs another bomb and launches another missile, the interceptor magazine protecting US bases and Israeli cities gets 1 round shorter. Every round spent intercepting a missile from Safi Mountain is 1 fewer round available for the next salvo. The global strategic implications of what Iran's mountains have demonstrated extend far beyond the Iran-US war's immediate battlefield. China, as reported by Asia Times, is now investing in deeper underground infrastructure for critical military and energy assets. North Korea has observed that Iran's underground missile program survived America's absolute conventional weapon. Underground military facilities in the Urals and elsewhere has absorbed the lesson that depth plus redundancy plus repair capacity can sustain operational continuity through sustained GBU-57 bombardment. The 1945 analysis noted that the Iran experience demonstrated that for states investing in hardened underground facilities, physical depth alone no longer guarantees immunity. But it also demonstrated that physical depth combined with dispersal, mobility, and repair capacity creates a survivability equation that the GBU-57 can degrade but cannot defeat. The bomb's 60-meter penetration limit, formidable against any facility designed before it existed, is not formidable against facilities specifically designed with knowledge of that limit. Iran knew about the GBU-57 when it built its deepest facilities. North Korea knows. China knows. Every adversary military planning cell on Earth now has the empirical performance data of America's most powerful conventional bomb against a real-world underground facility, because Iran's mountains provided the live fire test that no American exercise ever could. Trump told the world that Operation Midnight Hammer was a spectacular military success, in the narrow sense that it severely damaged Iran's declared nuclear enrichment capacity and set the program back by years. That assessment has some support in the evidence. but in the broader sense of eliminating Iran's ability to launch ballistic missiles at Israel and U.S. military bases from underground facilities spread across a country the size of Western Europe. The mountains told a different story. Bombed 20 times, still launching missiles. 90% of underground facilities at least partially operational. 1,000 missiles still in underground storage. 50 of 69 tunnel entrances cleared by bulldozers within 3 months. The GBU-57 is real. The B-2 is real. The bombs fell, the craters appeared. The smoke rose from Safa Mountain every night, and the Isfahan resident watched from his window and told the truth about what he saw. Every morning from those same mountains, the missiles rose into the sky,